In the silent theatre of the cosmos, objects move according to an ancient and unbreakable script, a celestial ballet choreographed by gravity. Planets orbit, comets trace their long elliptical paths, and stars drift through the void, all bound by the elegant laws of physics. We have come to trust this predictability. It is the foundation of our understanding. But in the late autumn of 2025, two entirely separate events, millions of kilometers apart, occurred in near-perfect synchronicity. Near Mars, the Hope orbiter, a marvel of human engineering, registered a sudden, inexplicable burst of Cherenkov radiation, a faint ethereal blue glow in the vacuum of space where no such glow should exist. At the very same moment, deep space tracking arrays on Earth noted something impossible. An interstellar visitor, a wanderer from another star system designated 3I Atlas, deviated from its path. It did not just change direction, it slowed down. This is, according to everything we know, a violation of the script. An object coasting through the solar system has no brakes, and yet this one did. We were prepared for a visitor. We were not prepared for one that seemed to stop and look around, and so we are left with a question that echoes in the quiet corridors of our observatories, a question that whispers to us in the dead of night. What if the most profound discovery in human history was not announced with a triumphant fanfare, but with a terrifying, impossible silence? Near Mars? To truly comprehend the depth of this mystery, we must first retreat from the precipice of the unknown and plant our feet firmly on the solid ground of what we know, or rather, what we thought we knew. Every great cosmic detective story begins not with the crime, but with the establishment of a peaceful, predictable world, so that the eventual disruption is all the more profound. Our story is no different. It begins with a faint speck of light, catalogued and filed away by automated systems, a whisper in the cosmic dark. The object designated 3I Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System, a network of robotic telescopes on Earth whose tireless, nightly vigil is to scan the heavens for any potential threats, any near-Earth objects on a collision course. But this was different. The software that flags these potential dangers also looks for outliers, for things that simply don't belong. And 3I Atlas did not belong. When an object is discovered, astronomers plot its course. They measure its speed and its direction, running the calculations backwards in time. For objects belonging to our solar system, comets, asteroids, dwarf planets, their paths inevitably trace back to a point within our own cosmic neighbourhood. A gentle, closed loop around our sun, an elegant ellipse. They are members of our family. But when the orbit of 3I Atlas was calculated, it did not form a closed loop. It was a hyperbola, the unmistakable signature of an interstellar traveller. Its velocity was too high, its angle of approach too steep. It was not falling around our sun, it was falling past it. This object was born in the darkness around another star, and had been journeying through the interstellar void for millions, perhaps billions of years, a silent messenger from a place we can only dream of. This was only the third such visitor ever confirmed. The first, Oumuamua, was a bizarre cigar-shaped enigma that tumbled end over end, accelerating in a way we still cannot fully explain. The second, Borisov, was more familiar, a comet much like our own, reassuring us that the chemistry of other star systems might be comfortingly similar. And now we had a third, Atlas. Astronomers around the world turned their most powerful instruments toward it, eager to learn its secrets. Data began to pour in. The great telescopes of Mauna Kea in Hawaii, the European Southern Observatory's very large telescope in the Atacama Desert of Chile, even the Hubble and James Webb Space Telescopes adjusted their schedules to catch a glimpse. The first analyses of its light, a technique we call spectroscopy, began to paint a picture. Spectroscopy is a beautiful form of cosmic forensics. By splitting the faint light of a distant object into its constituent colours, a rainbow-like spectrum, we can see the chemical fingerprints of the elements and molecules that are present. We saw the familiar signatures of frozen water, of carbon monoxide, and nitrogen gas sublimating from its surface as it drew nearer to the sun's warmth. It appeared at first to be a comet, a large one, perhaps several kilometres in diameter, but a comet nonetheless. It seemed this visitor would be more like the familiar Borisov than the perplexing Oumuamua. A sense of calm, academic satisfaction settled over the astronomical community. We had a new, well-behaved specimen to study. Its path was plotted with exquisite precision. It would cross the orbital plane of our solar system at a sharp angle, dive down towards the Sun, loop underneath the orbit of Mars, and then use the Sun's gravity like a slingshot to fling itself back out into the interstellar darkness, never to return. A fleeting postcard from another world. We calculated its trajectory down to the meter, its velocity down to the centimetre per second. We knew exactly where it was supposed to be and how fast it was supposed to be going at any given moment. This is the power and the comfort of celestial mechanics. It is a universe of clockwork precision, and as 3i Atlas began its journey through the inner solar system, another silent sentinel was going about its work, utterly unaware. Far from Earth, circling the red planet, is the United Arab Emirates Hope Orbiter. It is a weather satellite for a world that is not our own. Its mission is to study the thin, tenuous atmosphere of Mars, to understand its climate, its dust storms, its delicate dance of gases. It is not designed to look for interstellar objects. It is not equipped for astrophysics. Its instruments are pointed downwards, at the ochre deserts and pale pink skies of its host planet. One of its sensors, however, is designed to detect ultraviolet emissions. It is through these emissions that it can see the faint aurora on Mars and study how the solar wind strips away the planet's upper atmosphere. To do this, it must also be able to detect and filter out false positives, high-energy particles from deep space, cosmic rays, that can light up its sensors. One of the telltale signs of such a particle strike is a phenomenon known as Cherenkov radiation. Let us pause for a moment on this beautiful and strange effect. Imagine a boat moving through water. If the boat moves slowly, it creates gentle ripples. But if it breaks the speed of the water's waves, it creates a powerful V-shaped wake, a shock wave. Cherenkov radiation is the universe's equivalent for light. While nothing can travel faster than the speed of light in a vacuum, light itself slows down when it passes through a medium, like water, or glass, or even a gas. If a super-energetic charged particle, like a proton from a distant supernova, zips through that same medium faster than the light is moving within it, that particle will create a shock wave of light, a cone of faint, typically blue, light. It is the optical boom that announces the arrival of something moving impossibly fast. The Hope Orbiter is, of course, in the near vacuum of space. The Martian atmosphere is incredibly thin at its altitude. For it to detect Cherenkov radiation, a particle of immense energy would need to strike its sensor directly, or pass through a lens or a specific component of the spacecraft itself. This happens. It is a known and accounted for form of background noise. The onboard computers are programmed to recognize these tiny instantaneous single-point flashes and filter them out of the atmospheric data. They are considered instrumental artifacts, uninteresting. This is the world as it was. A predictable interstellar comet on a perfectly plotted course. A distant Martian orbiter methodically collecting weather data, quietly filtering out the background noise of the cosmos. Everything in its place, everything following the rules. The grand, silent clockwork mechanism of the solar system was functioning exactly as expected. And it is only by understanding this perfect, soothing predictability, this sense of absolute order, that we can begin to appreciate the true gravity of what happened next. Could it be that the universe has rules we are not yet aware of? Is it possible that the most important events are not the loud, explosive ones we watch for, but the quiet, subtle moments when the clockwork stutters and for a split second runs in reverse? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. They are formed when a very massive star dies and its core collapses in on itself. What is a black hole? A black hole is one of the strangest and most fascinating objects in space. It's an area of space-time where gravity is extremely powerful, because matter has been squeezed into a tiny space. This creates a gravitational pull so immense that there's a point of no return called the event horizon. Once anything crosses this boundary, a star, a planet, or light itself, it can never get out. You can think of space-time as a stretched-out rubber sheet or a trampoline. A normal star or planet would be like placing a baseball on the sheet, causing a small dip. A black hole, however, is like placing a heavy bowling ball in the centre. It creates such a deep well that anything that gets too close will roll in and become trapped. How do they form? The most common type of black hole, a stellar mass black hole, forms from the death of a massive star. Here's the basic process: a massive star's life. The process begins with a star that is at least 20 times more massive than our Sun. During its life, the star fuses elements in its core, creating immense outward pressure that balances the inward crush of its own gravity. Running out of fuel, eventually the star runs out of fuel. With no more outward pressure to support it, gravity wins. The star's core collapses in a fraction of a second. Supernova explosion. This sudden collapse triggers a massive explosion called a supernova. The outer layers of the star are blasted out into space, creating a beautiful and expanding cloud of gas and dust. Core collapse. While the outer layers explode, the massive core keeps collapsing under its own gravity. It gets squeezed into an incredibly small, infinitely dense point called a singularity. This singularity, with its immense gravity in a tiny space, is what forms the black hole. The first sign that something was wrong came not from a blaring alarm or a frantic discovery, but from a single, errant data point in a long, quiet stream of information. At the Jet Propulsion Laboratory in California, a postgraduate student monitoring the orbital tracking data for 3I Atlas noticed a discrepancy. It was a tiny deviation, an error so small it was initially flagged as a computational ghost, a miscalculation in the complex software that models the gravitational dance of the solar system. The object was a few hundred kilometers away from where it was predicted to be. This is not, in itself, unusual. Comets are famously unpredictable. As they warm, jets of gas and dust can burst from their surface, acting like tiny natural thrusters that can gently push the comet off its expected course. It's a phenomenon known as outgassing, and it is a normal, well-documented behavior. A team was assigned to run a standard analysis, to look for the telltale signs, an increase in the brightness of the coma, the dusty veil surrounding the object, or a change in its spectral signature indicating a fresh release of volatile gases. They aimed the world's most sensitive instruments at 3I Atlas, expecting to find evidence of this natural process. What they found was nothing. Less than nothing. In fact, the object's already faint coma seemed to have diminished. There was no dust cloud, no gas plume, no thermal signature of any eruption. Yet the deviation from its predicted path was undeniable and growing. It was not being pushed sideways. It was slowing down. Imagine coasting in a car on a perfectly frictionless road in a complete vacuum with the engine off. There is nothing to slow you down. You will simply glide forever. To decrease your speed, you must apply a force in the opposite direction. You must use the brakes, creating friction, or you must turn the car around and fire a rocket. 3I Atlas was in a near-perfect vacuum, on a frictionless path dictated by gravity. Yet it was braking. With no visible engine and no apparent friction. It was as if the very fabric of space in front of it had somehow become thicker, stickier, resisting its forward motion in a way that defied Newton's most fundamental laws. And then came the signal from Mars. Completely independently, the science team for the Hope orbiter was reviewing their daily data logs. They too found an anomaly. During the exact same time window that 3I Atlas had begun its impossible deceleration, the orbiter's ultraviolet spectrometer had registered a burst. But it was not the familiar single-pixel flash of a cosmic ray hitting a sensor. The data showed a faint but distinct and coherent cone of Cherenkov radiation. It wasn't centered on the spacecraft, but appeared to have blossomed in the empty space a few thousand kilometers away from it, perfectly aligned in the direction of 3I Atlas. This was, to put it mildly, impossible. A cone of Cherenkov light requires a medium. It requires a vast number of particles to be excited in unison. To see such a structure in the hard vacuum of space would be like seeing the V-shaped wake of a boat appear in the middle of an empty sky. Something had to be there for the light to travel through. Yet there was nothing. No gas cloud, no dust stream. Just the faint, ghostly blue afterglow of an event that, by all rights, should never have happened. The two anomalies, separated by millions of kilometers of empty space, were locked together in a perfect, terrifying synchronicity. One object, a visitor from another star, performing a maneuver that violated the conservation of momentum. The other, an ethereal burst of light that violated the known physics of the vacuum. They were two sides of the same impossible coin. Is it possible that we were witnessing a cause and an effect? Could it be that the mechanism used to slow the interstellar traveller was not a force we could see, but an invisible field projected ahead of it? What if that strange blue light was not an accident, but the brief visible footprint of space-time itself being bent to another's will? A discovery of this magnitude is not like a sudden thunderclap. It is more like the slow, inexorable turning of a great tide in the deep ocean. It begins in silence, far from public view, in the quiet, sterile glow of computer monitors and data terminals. The first communications were not panicked phone calls, but heavily encrypted emails, their subject lines deliberately mundane: orbital data query, spectrometer anomaly review. They flashed between the Jet Propulsion Laboratory in Pasadena, the European Space Operations Centre in Darmstadt, and the Mohammed bin Rashid Space Centre in Dubai. A triangle of quiet professional disbelief began to form across the globe. In these initial hours, every other possibility was exhausted with a rigorous, almost desperate intensity. Could the deceleration of 3I Atlas be an illusion, a trick of the light caused by some unmapped gravitational lensing? Models were run. The math said no. Could it be a previously unknown interaction with the solar wind or the sun's magnetic field? Simulations were executed on powerful supercomputers. The physics held firm. No known natural force could account for such a precise and powerful braking effect without leaving a trace. Could the Cherenkov light near Mars be an instrumental glitch, a flaw in the Hope orbiter's sensor that just happened to coincide with the orbital anomaly? The entire spacecraft was put through a remote diagnostic cycle. Its systems were flawless. One by one, the doors to conventional explanation were tried, and one by one they were found to be locked. When every familiar path leads to a dead end, the mind is forced to contemplate the unfamiliar. After 72 hours of ceaseless secret analysis, a consensus was reached. It was not a glitch, it was not an error, it was real. The information was escalated. A notification was sent to the International Astronomical Union, the globally recognized body responsible for cataloguing and making sense of the heavens. The alert, known as an astronomer's telegram, was distributed electronically to observatories and research institutions worldwide. It was a masterpiece of scientific understatement, a document stripped of all emotion, speculation, or wonder. It simply stated the observed facts. Object 3I Atlas had undergone a period of anomalous deceleration, inconsistent with known models of non-gravitational forces. This event was time-correlated with an unclassified transient luminous event, observed by a Martian satellite. It requested independent observational verification from all available assets. The effect of this dry technical message on the astronomical community was like a spark falling into a reservoir of dry fuel. A silent, coordinated global scramble began. On the high, arid plains of the Atacama Desert in Chile, the 66 massive dishes of the ALMA array stopped their patient study of distant galaxies and swiveled in unison like a herd of great metallic beasts to listen to the silence around 3I Atlas. They searched for the faint millimeter wave radiation that might betray a hidden energy source, a whisper of heat from a drive system. In the quiet hills of West Virginia, the Greenbank Telescope, the largest fully steerable radio dish on the planet, began to listen, straining to catch any hint of an engineered signal, a deliberate transmission buried in the cosmic static. Above the Earth, the great space observatories were retasked. The James Webb Space Telescope, with its unparalleled sensitivity, paused its deep field survey of the universe's dawn and turned its golden eye to the visitor, searching in the infrared for the faintest thermal signature that might hint at machinery or expelled energy. The Hubble Space Telescope began a series of long exposure observations, attempting to resolve any detail on the object's surface to see if it was a solid uniform body or something more complex. For those few weeks, humanity, without even knowing it, achieved a profound and singular focus. Thousands of our most brilliant minds across dozens of nations, representing the whole of our species, set aside their individual projects. The search for habitable exoplanets, the study of distant nebulae, the mapping of dark matter, all of it was paused. Every significant instrument of observation we possessed was pointed at a single, faint speck of light, coasting silently in the darkness beyond Mars. The mood within this secret global community was not one of fear, but of a deep, humbling, and almost sacred awe. It was the feeling of standing at the threshold of a new reality, of knowing that the answer to humanity's oldest question, "Are we alone?" was perhaps about to be answered. And as the new data poured in, another quieter search began. In the vast digital archives of astronomical data, researchers began to hunt for echoes of this event in the past. They cross-referenced old unsolved mysteries. The famous "wow" signal of 1977, a powerful, narrow-band radio signal that lasted for 72 seconds and was never heard again. Could its source have been something similar, passing through our system long ago? They re-examined the strange, inexplicable dimming of Tabby's star, the star whose light curve suggested some vast artificial structure might be in orbit around it. Were these isolated curiosities, or were they pieces of a much larger unseen puzzle? This search even reached back into the mists of history itself. Historians and anthropologists were quietly consulted. They looked again at ancient records, at Babylonian clay tablets, and Egyptian papyri that meticulously tracked the movement of the heavens. They searched for accounts of guest stars that did not behave as comets should, or celestial signs that were interpreted as divine messengers. These were not treated as literal evidence, but as a way to understand the human context of this moment. For all of our technology, we were no different from our ancestors, staring up at a strange new light in the sky, wondering what it meant, wondering if it had come for us. And through it all, the object itself remained completely, utterly silent. It broadcast no signal. It leaked no heat. It showed no signs of its impossible engine. It simply continued on its new, slower trajectory, a dark and inscrutable enigma. The public knew nothing. The world turned, blissfully unaware that the foundations of its science, its philosophy, and its religions were being shaken to their very core. What does a species do when faced with a truth for which it is not prepared? And could it be that this immense, coordinated, global listening and this act of unified attention was precisely the response the visitor was waiting for? What if the first test for a young, intelligent species is not whether it can speak, but whether it knows how to listen? In times of profound uncertainty, the human mind instinctively seeks patterns. We look to history, not just for answers, but for reassurance that we have been here before, that no challenge is entirely new. Faced with the silent enigma of Three-Eye Atlas, the scientific community began a monumental undertaking, a deep excavation of its own digital past. For more than half a century we have been collecting data from the cosmos, creating vast archives of information, immense libraries of numbers representing light curves, radio signals, and orbital mechanics. Most of this data has been catalogued, analysed, and set aside. But in this new, unsettling context, everything old was new again. Every unexplained data point, every instrumental error once dismissed as noise, was now a potential clue in the greatest detective story ever told. Teams of researchers, aided by powerful artificial intelligence algorithms, began to sift through these petabytes of information. They were not looking for a needle in a haystack. They were looking for the ghost of a needle, a faint impression left in the hay years ago. They were searching for a precedent, a sign that what was happening near Mars was not a singular event, but part of a larger, older pattern. And in the dusty digital archives of a late 1990s sky survey, they found it. It was called the C1998 K1 anomaly. C for comet, 1998 for the year of its discovery, K1 for the date. It was a faint trans-Neptunian object, a lonely chunk of ice and rock discovered drifting in the profound cold beyond the orbit of Neptune. Its trajectory was unusual, logged as mildly hyperbolic, meaning it was almost certainly an interstellar visitor, but the data was sparse. In the 1990s, our instruments were less precise, our ability to track such faint, distant objects far more limited. Its unusual path was noted, debated in a few obscure academic papers, and ultimately classified as a probable measurement error. The object was too dim, too far away, and it soon vanished back into the darkness, never to be seen again. Case closed. But now, a young astrophysicist in Germany, using an AI pattern recognition system, flagged it. The system had not been told to look for decelerating comets. It had been given the complex energy signature of the Cherenkov burst near Mars, and instructed to search for any similar electromagnetic events recorded by our spacecraft, and it found a weak but statistically significant match. In the autumn of 1998, The Galileo spacecraft, on its long and looping journey to Jupiter, recorded a burst of anomalous plasma wave interference as it passed through the gravitational domain of the planet Uranus. At the time, the event was logged as a consequence of Galileo passing through a complex part of Uranus's magnetic field. It was unremarkable. What was remarkable was this. When you plotted the location of the Galileo spacecraft during that interference burst and the position of the long-forgotten comet C1998K1 at that exact same time, they were aligned, and the comet, just like 3I Atlas, was the more distant of the two. A chill went through the research team. A coincidence of this magnitude was vanishingly improbable. With this new lead, they resurrected the old data from 1998. The original observations were crude by modern standards, but they were just enough. Using the far more powerful computers of the 2020s, they reran the orbital calculations. They modelled the comet's path, but this time they added a new variable. They programmed a hypothetical deceleration event to occur at the exact moment of the plasma wave burst recorded by Galileo. Suddenly all the old measurement errors, all the strange inconsistencies in its trajectory, vanished. The data fit. It fit perfectly. The ghost in the archive began to take shape. C1998K1 had not been a measurement error. It had slowed down, just like 3I Atlas. The discovery sent a new shockwave through the private international consortium studying the visitor. This was no longer a single isolated event. It was a pattern of behaviour, repeated across decades. And the pattern was unnervingly specific. An interstellar object enters the solar system. It proceeds to a specific point, in this case, near the orbit of a gas giant planet. It executes a braking maneuver of unknown physics, and this maneuver is accompanied by a secondary energy event, an electromagnetic footprint detected by the nearest human probe. This revelation was in some ways more terrifying than the first. The arrival of 3I Atlas could have been an accident, a 1 in a billion chance encounter. But two such events implied a methodology. It implied purpose. It suggested that these visitors were not just randomly wandering through our system, but were perhaps navigating it. They were stopping at designated points, like a driver pulling over at a familiar rest stop on a long highway. The questions became deeper, more unnerving. Why these locations? The space near Uranus and the space near Mars. They have little in common. One is in the frozen outer darkness of the solar system, the other in the relatively warm, crowded inner region. They are not gravitationally significant points. They are, from our perspective, entirely arbitrary, unless of course they are not arbitrary at all. What if there is something at these locations, something we cannot see, a piece of infrastructure left behind long ago, a navigational beacon broadcasting on a channel we don't know how to listen to, a refueling station, drawing energy from the vacuum in a way we cannot comprehend? The thought was staggering, that our solar system, which we had mapped and explored and considered our own backyard, might in fact be host to an invisible network, a system of roads and signposts for travellers to whom we are as invisible as ants on the pavement. Is it possible that we have been looking at our solar system all wrong? Could it be that we are not the sole occupants, but merely the newest tenants in a house that has been occupied, and perhaps even built, by others long before us? And what does it mean if these visitors are not explorers, but are simply commuters, following a well-worn path through a territory they know far better than we do? In the face of a mystery that touches upon the profound, the first duty of science is to maintain its composure. Before we leap into the abyss of extraordinary speculation, we must exhaust every possibility that lies within the known and the familiar. There is a principle that has guided scientific thought for centuries, a philosophical razor credited to the 14th century friar William of Ockham. It states that when presented with competing hypotheses, one should select the one that makes the fewest new assumptions. The simplest explanation, the one that relies on the laws of physics as we already understand them, is the most likely to be true. And so, as the global consortium of researchers stared into the silent data stream from 3I Atlas, they began to construct a narrative, not a story of aliens or ancient technologies, but a beautiful and complex story of rare natural phenomena. A sober, elegant, and entirely plausible explanation began to take shape, an explanation that, for a time, seemed to resolve the entire impossible affair. This became known, in the quiet corridors of research, as the magnetar fragment interaction model. It begins with the nature of the object itself. The model proposes that 3I Atlas is not a comet. its lack of a visible coma, its dark, non-reflective surface, all point to it being something else entirely. The hypothesis suggests it is a fragment of unimaginable density and exotic origin, a piece of the crust of a neutron star, or more specifically, a magnetar. Let us pause to consider what this means. A magnetar is the collapsed core of a giant star, a city-sized sphere so dense that a single teaspoon of its matter would weigh billions of tons on Earth. But its defining characteristic is its magnetic field, a field so powerful, 1,000 trillion times stronger than Earth's, that it defies easy comprehension. If a magnetar were to appear where our moon is, it would wipe the magnetic data from every credit card on the planet. The model posits that billions of years ago, a collision between two such stellar remnants, or a massive starquake on a single magnetar, ejected fragments of this magnetically saturated crust into interstellar space. 3I Atlas, then, is one such fragment, a wandering piece of ultra-dense hypermagnetized iron, silently journeying through the void for eons. This exotic origin is the key that unlocks the first mystery, the impossible deceleration. The explanation is a principle known as magnetic braking, or an eddy current brake. The physics is complex, but the analogy is simple. Imagine moving a powerful magnet through a copper tube. As the magnet moves, its field induces electrical currents, eddy currents, in the walls of the tube. These currents in turn generate their own magnetic field, one that pushes back against the original magnet, causing it to slow down smoothly and silently. There is no friction, no thruster, just the invisible interaction of magnetic fields. The question then is, what tube did 3I Atlas pass through in the empty space near Mars? The answer, the model suggests, lies in the unseen architecture of our own solar system. Space is not truly empty. It is filled with the solar wind, a stream of charged particles flowing from our sun. And carried within this wind are vast, complex structures, ropes and filaments of magnetic energy. These interplanetary magnetic flux ropes are like invisible rivers of magnetism, snaking their way through the solar system. The theory proposed that 3I Atlas, in its journey, happened to fly directly through an unusually dense and powerful one of these magnetic filaments. As the hypermagnetized object entered the filament, the conditions for magnetic braking were met. Powerful eddy currents were induced within the fragment, creating an opposing field that gently, but inexorably, slowed it down. No violation of physics was required. Newton's laws remained intact. This elegant model also provided an explanation for the second anomaly, the ghostly Cherenkov light. The interaction between a body as intensely magnetic as a magnetar fragment and a dense plasma filament would not be entirely passive. It would be a titanic event on a microscopic scale, a massive discharge of electromagnetic energy. The model calculated that this interaction would have created a focused, directed beam of high-energy charged particles, mostly electrons and protons, ejected from the point of interaction and sent hurtling through space at a significant fraction of the speed of light. This particle beam, invisible and silent, travelled millions of kilometres until it encountered the first significant object in its path, the planet Mars. As the beam struck the planet's upper atmosphere, it finally found the medium it needed. The Martian atmosphere, while over 100 times thinner than Earth's, is not a perfect vacuum. The particles in the beam, travelling faster than the speed of light within that thin atmospheric gas, would have created the precise effect the Hope orbiter witnessed, a cone-shaped shockwave of faint blue Cherenkov light. The orbiter didn't just happen to be in the right place at the right time. It saw the event precisely because it was orbiting the target that the particle beam was destined to hit. The final test of any good theory is whether it can explain past events. The researchers turned the magnetar fragment model to the C1998 K1 anomaly, and here too the pieces fit with a satisfying click. C1998 K1 was also a magnetar fragment. Its deceleration near Uranus was caused by the same magnetic braking effect, likely triggered as it passed through a magnetic filament entangled with Uranus's own powerful and chaotic magnetosphere. The plasma wave interference detected by the Galileo spacecraft was the signature of this very interaction, the noise of the magnetic river the fragment was fording, and so for a time there was a sense of profound intellectual relief. The mystery, it seemed, was solved. There was no alien intelligence, no technology beyond our comprehension. There was only a rare and beautiful confluence of natural events, a story of an ancient stellar collision, a magnetic wanderer, and the unseen magnetic weather of our own solar system. It was a universe that was still strange, still wonderful, but ultimately a universe that followed the rules. The cosmos was not haunted by ghosts or gods, but was simply a grander, more complex and more elegant machine than we had previously imagined. The feeling was one of reassurance, a comfortable return to a world we understood. A world where humanity could, once again, feel it was alone, but safe, in the vast, silent and ultimately logical darkness. There is a serene and profound beauty in a theory that elegantly explains the unknown. The magnetar fragment interaction model was one such theory. It was a port in a storm of intellectual chaos, a comforting narrative that placed the strange behaviour of 3i Atlas firmly within the realm of known, if exotic, physics. It allowed the scientific community for a brief time to breathe a collective sigh of relief. The universe, it seemed, was still playing by the rules, but science is a relentless and unsentimental endeavour. A theory, no matter how beautiful or comforting, must do more than simply explain the broad strokes of a mystery. It must withstand the fiercest scrutiny. It must account for every detail, every nuance, every stubborn data point that refuses to be ignored. And as the global network of telescopes continued their silent, ceaseless vigil, the beautiful theory began to fray at the edges. Small, unsettling details emerged, details that, like a single loose thread, threatened to unravel the entire tapestry. The first thread to be pulled concerned the problem of efficiency. The magnetic braking model was sound in principle, but the numbers, when analysed with greater precision, simply did not add up. To achieve the observed deceleration on an object with the estimated mass and velocity of 3 Atlas, the interplanetary magnetic flux rope it passed through would have needed to be of a power and density orders of magnitude greater than anything ever observed or predicted within our solar system. It was, according to one senior astrophysicist, like claiming a freighter ship was stopped by running into a spider's web. It was theoretically possible if the web were made of carbon nanotubes a mile thick, but it required the convenient existence of a structure for which we have no other evidence. Furthermore, the deceleration itself was too clean. An interaction with a turbulent, chaotic river of solar plasma should have been a messy affair. The object should have tumbled, wobbled, and its rate of deceleration should have fluctuated wildly as it passed through the densest parts of the filament. Instead, the data from 3i Atlas showed a deceleration curve of impossible smoothness, a graceful and precise reduction in velocity that spoke not of a chaotic collision with nature, but of a controlled and deliberate application of a force. It was the difference between a car stopping by crashing into a forest and a car stopping with an advanced computer-controlled braking system. Both stop the car, but their signatures are worlds apart. The second thread concerned the geometry of the event. The natural model required a beam of particles to be ejected from the magnetic interaction, travel millions of kilometers, and strike the Martian atmosphere to create the Cherenkov light. But the light cone observed by the Hope orbiter was unnervingly perfect. Its edges were sharp, its structure exquisitely defined. A natural particle explosion, like the debris from a supernova, expands in a diffuse, ever-widening spray. For this event to work, the particle beam must have been highly collimated, that is, focused and directional, like a searchlight. Nature can occasionally produce such things, in the form of astrophysical jets from black holes, but that requires energies and mechanisms on a galactic scale, not from a quiet interaction in interplanetary space. And then there was the sheer, breathtaking improbability of its aim. For that perfectly focused beam to just happen to be pointed directly at the planet Mars, a tiny target in the vastness of the solar system, stretched the definition of coincidence to its breaking point. For it to happen once was remarkable. But for the same basic geometry to be repeated, a distant deceleration linked to an energy event near a planetary body, as seen in the C1998 K1 anomaly, was a coincidence that defied all statistical logic. The principle of Occam's razor began to cut in the other direction. What is the simpler explanation? That two separate, impossibly rare natural events, each composed of a cascade of smaller improbabilities, happen to occur within 30 years of each other. Or the single, albeit terrifying assumption that the pattern exists because the events were deliberately engineered to be precise and repeatable. These flaws were troubling. They were the subject of intense hushed debate in online forums and secure video conferences. But for many, they were not yet fatal to the natural theory. They were anomalies that required refinement of the model, not its outright rejection. Then came the final, unanswerable blow. After weeks of patient observation, the team operating the James Webb Space Telescope, which had been tracking the object's trajectory with unprecedented accuracy, submitted a new report. Their analysis confirmed the smooth deceleration. But it also showed something more. After the main braking event was complete, after 3i Atlas had settled into its new, slower path, it made a correction. It was an impossibly subtle maneuver, a tiny nudge, a minute change in its vector that was detectable only by the most sensitive instrument ever built by human hands. Atlas had not just slowed down, it had steered. This single data point shattered the natural explanation completely. Magnetic braking is a passive, symmetrical force. It can slow an object down, but it cannot guide it. It cannot make a fine-tuned course correction. To steer, an object must apply a directed asymmetrical thrust. It must have a rudder, a thruster, an engine. It must possess the ability to choose its own path. And once again, the hunt for the signature of this thrust. A puff of gas, a bloom of heat, a trail of ions, yielded absolutely nothing. The port in the storm was gone. The researchers were adrift once more, in an ocean of data that now pointed in only one deeply unsettling direction. The comforting idea of a rare natural encounter had been dismantled piece by piece by the stubborn facts. What was left was a portrait of something that exhibited all the hallmarks of deliberate intelligent design, immense efficiency, geometric precision, purposeful repetition, and now active guidance. The universe was no longer a logical if complex machine. It was haunted once more. When a phenomenon displays a level of precision and control that far exceeds the chaotic grasp of nature, at what point do we stop searching for a natural cause? At what point must we finally accept the evidence before us and gather the courage to call it design? We have come to a great threshold in our story. We have followed the data, we have trusted in our instruments, and we have honoured the scientific method. We built a plausible, elegant narrative based on the laws of nature as we know them, and we watched as new, stubborn facts dismantled it piece by piece. The path of conventional explanation has led us to a sheer cliff, a place where our current maps are no longer useful. We must now do what science has always done at such moments. We must be brave. When all known explanations have been exhausted, it becomes our intellectual and moral duty to consider the one we have held in reserve. We now step away from the solid ground of direct observation and enter the realm of the structured thought experiment. Let us, with the same sobriety and rigour we have applied thus far, dare to contemplate the engineered hypothesis. Let us begin by ceasing to call 3i Atlas a comet or a fragment. Let us call it what the data now suggests it is, an artifact, a machine. And if it is a machine, it is of a type that has been theorised about for over half a century, a silent and patient messenger known as a Bracewell probe. First proposed in 1960 by scientist Ronald Bracewell, such a probe would be an autonomous robotic vessel, sent by an advanced civilization not to conquer, but to seek, to listen, and to make contact with other emerging technological life forms across the galaxy. If we accept this as our working model, then the characteristics of 3i Atlas are no longer mysterious. They become its design features. Its dark, non-reflective surface is not a geological quirk. It is a form of advanced stealth technology, an adaptive camouflage designed to minimize its visibility as it travels through potentially inhabited systems. Its journey across millions of years is not a testament to its durable geology, but to an engineering philosophy of unimaginable patience and longevity. The artifact is ancient, and it is almost certainly autonomous, its actions guided by an artificial intelligence of profound complexity. Within this framework, its recent actions are not anomalies, but the execution of a pre-programmed protocol. The impossible deceleration is no longer a mystery of physics, but a logical, tactical maneuver. The probe was likely coasting in a dormant, energy-saving state for millennia. Upon entering our solar system, its passive sensors would have detected the unambiguous signature of technology, the faint, ever-expanding shell of radio waves from our televisions, our radios, our global communications that has been leaking out into space for the last century. This detection would have triggered its primary mission protocol. It awoke. and its first order of business upon discovering a person in the house was to stop hiding in the hallway and quietly enter a room to observe. It slowed down, it stopped being a traveller and became a watcher, and the mysterious Cherenkov light. In this new model, it was not a random byproduct. It was an action. It was a signal. But what kind of signal? Let us consider 3 chilling possibilities. First, it may have been a test. The probe knows we exist, but it does not know the extent of our capabilities. To find out, it performs an action that is subtle, but definitively artificial. It directs a focused particle beam, a feat of physics far beyond our own, at the most distant planetary body where it might guess we have a presence. It pings Mars. It is the cosmic equivalent of knocking on the outer garden wall to see if the inhabitants of the house even notice. Our detection of the event via the Hope orbiter was our answer. We passed the test. We proved we are a species that has taken its first tentative steps into our own solar system. Second, it may have been a form of safe first contact, a way of saying hello that is physically unambiguous but informationally sterile. The signal demonstrates a mastery of physics that is clearly not natural, establishing its artificiality beyond any doubt. Yet it contains no complex message, no language, no demands. It avoids the profound cultural and philosophical shock of a direct, information-rich message. It is an introduction, not a conversation. It is a single, perfect, impossible blue flower left on our doorstep in the dead of night. The third possibility is perhaps the most alien of all. What if the signal was not for us? What if the artifact, after its long journey and its powerful braking maneuver, needed to recharge its energy reserves? It is possible the particle beam was an energy harvesting tool, fired at the Martian ionosphere or magnetic field to draw power in a way we do not comprehend. Its purpose was entirely internal. Our detection of the Cherenkov light was, from its perspective, completely incidental. We were merely witnessing the silent, indifferent process of a machine refueling itself. This engineered hypothesis casts the historical C1998 K1 anomaly in a new, even more profound light. It was not a separate event. It was part of a survey. Perhaps it was a different probe, a precursor. Or perhaps it was the very same artifact on a previous pass through our system decades ago, before our radio signature was strong enough to trigger its primary protocol. It noted the system as interesting, perhaps for its gas giants, and continued on its way. Now, upon its return, it has found that the planet third from the Sun has blossomed with technology. The survey has become a focused observation. We are no longer discussing a cosmic coincidence. We are discussing a systematic, long-term project of galactic reconnaissance, of which we are now the primary subject. This thought should be held with a sense of profound gravity. We are not dealing with the idea of little green men in flying saucers. We are confronting the sober possibility of a vast, ancient, and deeply patient intelligence, whose motivations are entirely unknown, and whose capabilities operate on a level of physics that is, to us, indistinguishable from magic. We are a child in a quiet house, who has just realized that a silent, unseen adult has been watching us play for a very long time. If we are to accept this as our new working model, if we are to believe that we are truly observing a machine, a probe, an artifact, then the next question we must ask is not who sent it, or why. The next question is a practical one. How? How have its engineers conquered the laws of physics as we know them? How does one build a ship that can cross the stars, brake with utter silence, and steer with no visible engine? We are about to enter a realm of deep speculation. This is a thought experiment, a journey into the farthest reaches of what human science considers to be possible. Let us imagine the conference rooms and laboratories where our world's greatest theoretical physicists are gathered. They are faced with a set of observed facts: silent, reactionless propulsion, immense energy output with no waste heat, the projection of a highly focused particle beam. Their task is to build a theoretical framework, a blueprint for a physics that could make such a machine possible. Their first and greatest challenge is the problem of propulsion. The artifact, 3i Atlas, moves in a way that seems to casually defy Newton's third law. Our own spacecraft are prisoners of this law. To move forward, we must violently throw mass backward, be it the hot gas from a chemical rocket or the ions from an electric thruster. This is the brute force approach. The artifact, however, is a study in elegance. It does not push against anything. It simply moves. The emerging theoretical model to explain this is known as an inertial manipulation drive. It is a concept so advanced, It borders on the philosophical. Let us try to visualize it. An object's inertia is its inherent resistance to being accelerated or changing its direction. It's the property of matter that gives it a sense of stubbornness. According to our current understanding, this property arises from an object's interaction with a fundamental energy field that permeates all of space, known as the Higgs field. An object's mass, and therefore its inertia, is a measure of how much it drags against this field. Our technology is designed to overcome this drag with brute force. The hypothesis is that the artifact's technology does not fight the drag. It changes the field itself. Imagine a drive system that could project a localized warp in the Higgs field directly in front of the probe. In this warped region, the fundamental property of inertia would be temporarily and locally altered. The probe would not need a thruster. It would simply create a path of least resistance for itself through the fabric of space-time, and then allow the momentum of the universe to carry it effortlessly along that path. To slow down, it would do the opposite, projecting a field that increases its inertia, making it profoundly heavy and resistant to motion relative to the cosmic background. To steer, it would create a subtle gradient, a gentle slope in the field, allowing it to drift in a new direction with perfect precision and silence. This would be a truly reactionless drive. It would not expel mass. It would not generate a plume of fire. It would be the propulsion of a ghost, a machine that coaxes the universe into letting it pass, rather than forcing its way through. Of course, the ability to warp a fundamental field of the universe would require access to an almost unimaginable amount of power. And this brings us to the second mystery, the probe's power source. It radiates no heat, carries no visible fuel, and is too far from the sun for solar power. Yet, it performs maneuvers that would, by our standards, require the output of a nation's entire power grid. Where does this energy come from? The most promising and most mind-bending theory lies in the very nature of empty space. Our understanding of quantum mechanics tells us that a vacuum is not empty at all. It is a roiling, seething cauldron of potential, filled with what we call quantum foam, or zero-point energy. Countless virtual particles are flashing into and out of existence in every cubic centimetre of space, at every moment in time. The amount of energy locked away in the fabric of the vacuum is, by our calculations, astronomically vast. For us, this energy is untouchable, a tantalizing but inaccessible reservoir. The hypothesis is that the artifact's engineers have solved this problem. The probe is powered by a zero-point energy extractor. It possesses a mechanism that can tap directly into the seething energy of the void. It does not need to carry fuel because the entire universe is its fuel tank. It does not generate waste heat because its process is likely near 100% efficient, a direct conversion of vacuum energy into usable power. It is the ultimate form of sustainable energy, drawn from the very fabric of reality itself. This would also reframe the Mars event. The particle beam might have been a tool used to prime the local vacuum, creating a state from which energy could be more easily extracted to recharge the ship after its braking maneuver. Finally, there is the question of the particle beam itself. How to create and aim such a perfectly focused beam of matter? A traditional particle accelerator, like the Large Hadron Collider, is a monstrously large and complex piece of machinery. The artifact is at most a few kilometers across. The theory here is that its technology operates on the same principle as its power source. If you can manipulate the quantum foam to extract its energy, you can likely manipulate it to do other things as well. Perhaps the probe can pluck virtual particles directly from the vacuum, imbue them with real energy and momentum, and then release them in a perfectly coherent laser-like beam. It would not be a particle accelerator, but a particle creator, a device that treats the fundamental building blocks of reality as a palette from which to paint. And so, a terrifyingly coherent picture of the artifact's inner workings begins to emerge. It is a machine whose an inertial drive manipulates the local fabric of space-time to allow for effortless motion, and a particle projector weaponizes the vacuum itself. It is a trinity of technologies, all born from a single profound breakthrough, the mastery of the quantum realm. It is a physics that treats the fundamental constants of the universe not as immutable laws, but as variables to be tuned and controlled. If an intelligence possesses such godlike power, the ability to draw limitless energy from nothingness and to move without effort among the stars, what could it possibly want from a small blue world like ours? What is the purpose of such a silent, patient, and impossibly powerful messenger? Let us now explore that very question. Having dared to imagine the science of the builders, we must now attempt an even more difficult task, to imagine their motives. This is a form of intellectual archaeology, an attempt to reconstruct a mind, a culture, a history, from a single inscrutable artifact. We must be humble in this endeavour. An ant, observing a human place, a marker in the ground, could never comprehend the complex motives behind it. A property line, a future garden, a memorial to the past. Our attempts to understand the purpose of this probe are likely just as limited, but we must try. Let us consider the three primary hypotheses that began to circulate among the secret consortium studying the artifact. The first, and most benign, is the hypothesis of the librarian. Imagine a civilization so ancient, so advanced, that it has moved beyond the needs of conquest, expansion, or even survival. What then becomes its purpose? Perhaps it is to know, to witness, to compile a record of the universe's fleeting and beautiful experiments with life. This civilization has become the galaxy's archivist. It sends out countless probes, like our 3 Atlas, not as messengers, but as silent, scholarly observers. Their mission is to wander the stars for eons, listening for the faint telltale signs of emerging intelligence. When a probe detects a new technological species, its protocol is simple: stop, watch, and record. It would gather information passively, absorbing our radio waves, our television broadcasts, our satellite communications. It would learn our languages, our history, our art, our science. It would watch us with the patient, non-judgmental gaze of a scholar, studying a rare and fascinating new life form. In this scenario, the probe's silence is a sign of respect, a form of non-interference. It is not here to contact us, to uplift us, or to harm us. It is here simply to add the story of humanity to a single, glorious line in the great cosmic encyclopedia. See entry for Sol 3, a carbon-based water-world civilization. Technological status, emergent, notable for chaos, music, and fleeting moments of grace. This is a profoundly humbling and perhaps lonely possibility. That the greatest event in our history is, for them, a footnote. The second hypothesis is more pragmatic and more unsettling in its indifference. This is the motive of the surveyor. In this model, the intelligence behind the probe is not interested in us at all. We, and our civilization, are merely a distracting local feature. Their true interest is in the raw materials of our solar system. An advanced civilization would still require resources, rare elements, specific isotopes, stable gravitational points for construction, or perhaps forms of energy we do not yet recognize as valuable. The probes, in this scenario, are prospectors, engaged in a systematic multi-million-year survey of the galaxy's star systems to map out their resources. The probe's stop at Uranus in 1998 was not to observe the planet, but perhaps to analyze the composition of its atmosphere for helium-3, a potent fuel for nuclear fusion. Its deceleration near Mars was not to get a better look at us, but perhaps to analyze the asteroid belt that lies just beyond, a vast repository of metals and minerals. Its silence is not a matter of respect, but of utter disinterest. A human surveyor, mapping a jungle for its timber or mineral wealth, pays little attention to the chattering of the monkeys in the trees unless they become a direct nuisance. In this scenario, we are the monkeys. The silence of 3i Atlas is the silence of a being that simply does not care that we are here. And the question it raises is a chilling one. What happens if it finds what it is looking for? The third hypothesis is the darkest. It is born from a grim logical calculus of survival known as the dark forest theory. This theory models the galaxy not as a potential community, but as a dark forest filled with silent hidden hunters. In this forest, there are 2 fundamental rules for survival. First, do not make a sound. Second, if you hear a sound, you must eliminate its source. This is because you can never know the intentions of another civilization. If they are peaceful, you have no way of being sure. If they are hostile, giving them time to develop could mean your own extinction. Therefore, the only logically safe move when encountering another intelligent species is a preemptive strike. In this terrifying model, the probe is not a librarian or a surveyor. It is a sentry, a silent, automated tripwire. Its purpose is to drift through the void, listening. For 100 years, humanity has been making sound. Our radio leakage has been spreading out from Earth like a ripple in a pond, announcing our presence to anyone or anything that might be listening. Our signal was the twig that snapped in the dead of night. The probe, 3 Atlas, has stopped because it has heard us. Its deceleration and course correction are not for observation, but for triangulation. It is gathering precise data on our location, our energy output, our technological level. Its silence is the focused, patient silence of a hunter that has found its prey, and its next action may be to send a single message back to its creators, a message that simply says, "I've found one." These 3 possibilities, the librarian, the surveyor, and the sentry, haunt the minds of those who watch the artifact. But these are just stories, born from our own hopes and fears. We have no way of knowing the truth. However, 3 Atlas is no longer just watching. Its new subtle course correction is not random. It is on a precise trajectory towards a new destination within our solar system, a destination that may give us our first real clue to its intent. What if the probe is finished listening, and is now on its way to its next appointment? A machine built with purpose moves with purpose. The subtle course correction of 3i Atlas was not a random drift. It was the precise calculation of an intelligence laying in a new course. As observatories around the world tracked its new vector, a single, unbelievable destination became clear. The artifact was not heading for Earth. It was not heading for the Moon. It was heading for a point in space that is, in a way, neither. It was aimed directly for the second Earth-Moon Lagrange point, or L2. Let us pause for a moment to understand the profound significance of this destination. In any system of 2 large orbiting bodies, like our Earth and Moon, there are 5 specific points where the gravitational forces and the orbital motion of the bodies balance out. An object placed at one of these Lagrange points will remain in a stable or semi-stable position relative to the larger bodies. They are gravitational anchors, natural parking spots in the void. The L2 point is located approximately 400,000 kilometers from us, directly on the far side of the Moon. From this vantage point, the Earth is forever eclipsed by the lunar sphere. It is a place of perpetual shadow, a location of supreme quiet, shielded from the constant radio noise of our world. It is a natural hiding place, so natural in fact that it is the very location we chose to place our most sensitive eye on the universe, the James Webb Space Telescope. The artifact was not just heading for a mathematically convenient point in space, it was heading for our back door. With a known destination and a known velocity, the world's astronomers could now make a calculation that had never before been made in human history. They calculated the estimated time of arrival for an alien probe. The numbers were checked, rechecked, and confirmed by a dozen different institutions. A date was set, a time was marked, and a silent, secret countdown began. Across the planet, in every major observatory and space agency, clocks were synchronized to a single future moment. 03:14, Coordinated Universal Time, on the 7th of January 2026. For the first time, humanity had an appointment with the unknown. The 2 months leading up to this date were a period of intense, secret, and breathtakingly complex preparation. A silent global ballet of machinery was set in motion. The first and most delicate task involved the James Webb Space Telescope itself. To observe the artifact's arrival, the telescope would have to be turned to look backwards, toward the approaching object, a maneuver that risked exposing its sensitive cryo-cooled instruments to the warm radiation of the Earth and Moon. It was a risky, unprecedented move, but the decision was unanimous. The potential discovery was worth any risk to the machine. On the other side of the Moon, the Lunar Gateway, the small space station being assembled in a stable halo orbit, became the designated primary observation post. The astronauts aboard, a crew of 4 international specialists, ended their geological surveys. Their new mission was to prepare every sensor, every camera, every spectrometer on the station for the arrival. They became the designated eyewitnesses for all humanity, our sentinels on the farthest frontier we had ever established, and the call went out to every other asset. Satellites in Earth orbit were repositioned. The great radio dishes of the Deep Space Network in California, Spain, and Australia cleared their schedules to focus all their listening power on the L2 point. Probes as far away as Jupiter and the asteroid belt were programmed to turn their instruments towards the inner solar system at the designated hour, to watch for any ripple, any energy signature, any sign of the arrival. It was the most ambitious, coordinated observational effort in history, a planetary-scale endeavour to watch a single empty point in space behind our moon. While the world's governments maintained a disciplined public silence, a secret of this magnitude could not remain entirely contained. Amateur astronomers, a global network of dedicated and brilliant observers, began to notice the strange behaviour. They saw the James Webb deviate from its observation schedule. They tracked the unusual manoeuvres of high-orbit satellites. They noted that for weeks, every major radio telescope on the planet seemed to be pointing at nothing at all. On internet forums and encrypted chat servers, the rumours began to fly. Fragments of data were pieced together. The whispers grew louder. The unofficial world began to sense that the official world was holding its breath. Inside the institutions, the atmosphere was one of quiet, electric tension. Sleep became a luxury. The faces of flight directors and mission scientists seen over secure video links were etched with fatigue, but their eyes were bright with a profound, historic sense of anticipation. They were no longer just scientists. They were custodians of a secret that would redefine the human story. They were waiting. The whole of their professional lives, the whole history of their science, from Galileo to Einstein to Hubble, had led to this moment. They had spent their careers listening for a whisper from the stars, and now the clock was ticking down to a shout. The final hours pass in a state of suspended animation. At the Green Bank Observatory in West Virginia, radio astronomers watched their monitors, which traced the silent hiss of the cosmic background. At the European Space Operations Centre in Germany, engineers monitor the vital signs of the Lunar Gateway, their eyes fixed on the heartbeats of the 4 astronauts floating in the quiet dark. And at the Space Telescope Science Institute in Baltimore, the flight team for the James Webb watches as their priceless instrument stares into the blackness, waiting for its visitor to arrive. The final minutes tick away. A species holds its breath. We have asked what it is, how it works, and why it has come. Now, as it approaches its destination in the quiet shadow of our own moon, only one question remains. What will it do next? The world, unaware, continues its nightly rhythm. Lights glitter across the continents. People sleep and dream and worry about the small immediate things that make up human life. But in a few dozen quiet, sterile rooms scattered across the globe, humanity has become a single, unified consciousness. A silent planetary vigil, its attention focused on a single, invisible point in the shadowed void behind the moon. The clocks on the mission walls, synchronized to the atomic second, tick past 03.13 and 59 seconds, coordinated universal time. The countdown ends. 03:14, the moment of arrival, silence. The second hand on the clock sweeps past the designated moment. 1 second. 5. 10. The deep rhythmic pulse of the music is the only thing that moves. On the screens displaying the data from the James Webb Telescope, the field of stars remains unchanged. In the audio feeds from the radio arrays, the gentle universal hiss of the cosmic background continues, unaltered. On the faces of the mission controllers, a flicker of the deepest, most primal fear for a scientist. The fear of being wrong. Had they miscalculated? Was the subtle course correction just a meaningless drift after all? Had they mobilized the entire astronomical infrastructure of their planet to stare at nothing? For a full, agonizing minute, the universe holds its perfect, indifferent poise. And then it happens. It does not begin with a flash, but with an absence. The first sign comes from the James Webb. On its hypersensitive infrared sensors, a single pixel in the center of its view begins to cool. Then the pixels around it. A circle of profound cold begins to expand, as if a hole is being opened into a place where the concept of heat does not exist. The background temperature of space, already a mere 3 degrees above absolute zero, plunges into the microkelvins. Energy is not being blocked. It is being actively, impossibly, removed from the vacuum. As the cold spot grows, a sphere of perfect blackness coalesces at its center. It is not the black of a shadow, or the black of an object painted to absorb light. It is a region of absolute nothingness, an ontological void that emits no light, no heat, no radio waves, no neutrinos. It is a perfect 3-dimensional hole in reality. The artifact has arrived, but it has cloaked itself in a field that erases its own existence from the electromagnetic spectrum. On the Lunar Gateway, the astronauts see nothing through their viewports, but their instruments scream. The station's gravimeters, designed to measure the faint pull of lunar mascons, lurch as they detect a sudden, localized gravity well. A mass equivalent to a small mountain has just materialized from nothing at the L2 point. Simultaneously, their magnetometers register the bloom of an intricate, multi-layered magnetic field, pulsing with a complexity that seems less like physics and more like mathematics, a silent magnetic symphony. And on Earth, the radio astronomers, listening with the combined power of a planet, also detect the event, but not as a sound. For a precisely measured period of 3 seconds, the cosmic microwave background radiation, the faint afterglow of the Big Bang itself, is momentarily and impossibly smoothed. The random, chaotic static of creation, coming from the direction of L2, becomes eerily calm, as if the artifact's field has reached out and gently soothed the quantum foam of space-time in its immediate vicinity. Then, the true spectacle begins. From the center of the sphere of blackness, something emerges. It is not a ship of metal and lights. It is a structure of pure, coherent light, a vast, intricate, and slowly rotating three-dimensional fractal. It is a geometric object of impossible complexity, branching and unfolding in on itself, patterns repeating at ever finer scales. It glows, but does not illuminate the space around it. It seems to be a projection, a hologram, but one woven from the very fabric of light itself. It is silent, graceful, and so profoundly complex that the human mind struggles to comprehend its form. It is like watching a living theorem, a beautiful and terrifying piece of alien mathematics, unfold in the dark. This silent, luminous performance continues for a specific and deliberate duration. It lasts for exactly 11 minutes. A few frantic physicists in a control room in Houston quickly realize the significance. 11 minutes is the time it takes for light to travel from the Earth-Moon L2 point to the sunlit plains of Australia, the part of the Earth's surface teeming with life, that was then closest to being in direct line of sight. It is a deeply ambiguous and poetic choice. And as the 11th minute concludes, the event ends as it began. The fractal light structure collapses back in on itself, folding its impossible geometry down into a single point, and vanishes into the sphere of blackness. The complex magnetic field contracts and disappears. The gravity well evaporates. The cold spot warms rapidly, returning to the ambient temperature of deep space. And finally, the sphere of blackness itself dissolves into nothing, like a drop of ink in an infinite ocean. It is over. The space at L2 is empty again. The control rooms remain silent for a long time. They have witnessed a miracle, a spectacle of physics so advanced it borders on the divine. But what was it? It was not an act of aggression. It was not a message they could decipher. No ship remains. No artifact is there to be studied. All that is left is the data, the terabytes of recordings from a dozen different instruments, all of which tell the same impossible story. It was a demonstration, a greeting, a warning, a work of art, the booting up sequence of a machine, any or all of these things. The only certainty is that the mystery has not been solved. It has deepened into an abyss. Was it a message intended to be understood, or were we merely the silent, unnoticed witnesses to a beautiful and complex diagnostic display, a light show never meant for our eyes at all? In the hours and days following the climax at the L2 point, a strange and profound quiet settled over the global consortium. The frantic energy of the countdown, the electric tension of the arrival, all of it evaporated, leaving behind a silence that was not empty, but heavy with the weight of new knowledge. The space behind the moon was physically empty once more, but the world's computer servers, its data archives and its hard drives were now haunted by a digital ghost of exquisite detail. They contained the complete multi-sensory recording of an impossible event, a digital fossil, and now the long, painstaking work of paleontological reconstruction had to begin. The secret, informal network of researchers was formalized into a new, global organization, operating under the highest levels of classification. It was given a simple, evocative name, the Chimera Task Force. The name was chosen for the mythological beast made of disparate, unnatural parts, for what they had witnessed was not a single, coherent thing, but a chimera of light, gravity, magnetism, and cold, all fused together by a science that was not their own. Physicists and astronomers were joined by mathematicians, cryptographers, linguists, data theorists, and even philosophers, all sworn to a secrecy more profound than any in human history. Their task: to analyze the ghost. Terabytes of raw data were distributed through secure networks. It was the most complete dataset for a single celestial event ever recorded. And as the analysis began, a humbling and deeply unsettling pattern emerged. Every new piece of information, every new discovery found within the data did not answer questions. It only created newer, more profound ones. They had hoped to find clarity. Instead, they found layers of infinite, maddening complexity. The first layer was the gravitational signature. The data from the Lunar Gateway's gravimeters was stunning. The artifact's mass had not simply appeared, it had fluctuated. The gravity well had pulsed and shifted with incredible speed and precision, creating complex waveforms that defied all known models of general relativity. It was as if the probe was not a static object possessing mass, but a dynamic entity that could manipulate its own gravitational field on a millisecond by millisecond basis, perhaps even cycling its mass through dimensions we cannot perceive. The data was clear, but the meaning was incomprehensible. It was the recording of a conversation with gravity itself. The second layer was the magnetic field. When the intricate pulsing patterns were fed into the world's most powerful cryptographic analysis programs, the results were immediate and conclusive. This was not a natural magnetic field. It was a structured, information-rich signal. It contained all the mathematical hallmarks of a language: immense complexity, non-repeating but logically consistent structures, and what appeared to be a form of nested syntax. The cryptographers were ecstatic and then horrified. They had intercepted a message of unparalleled sophistication, but they had no key, no context, no Rosetta Stone. It was like finding a book written in a language that used a different form of logic. They could prove it was a language. They could admire its structure, but they could not read a single word. Was it the probe's internal operating system? A broadcast to its distant home? Or was it a message directed at us? A message so complex that our minds are simply not the correct shape to understand it. The third and most beautiful layer was the light fractal. Mathematicians analyzed its geometry for months, finding it to be a dynamic, evolving structure based on principles of higher dimensional mathematics that, for humans, were purely theoretical. It was a living visualization of a branch of math we had not yet invented. The spectral analysis of its light was even more baffling. The light was not composed of photons emitted from excited atoms, as all light we know is. It had a perfectly flat, uniform spectrum across all wavelengths, a physical impossibility for any natural or man-made light source. It was as if the object was not emitting light, but was made of it, a stable, solid structure of pure energy. A senior biologist brought into the task force to provide an outside perspective offered the most chilling analogy. She noted that the structure's immense complexity, its nested patterns, and its apparent function as a form of non-destructive display was functionally identical to the way living organisms use DNA. DNA is a near-perfect data storage system, carrying the blueprint of an entire organism in its intricate coils. What if, she proposed in a hushed conference call, we weren't watching a technological display? What if we were looking at the soul of the machine, a visual representation of its code, its memory, perhaps even the biological and cultural history of its creators? The artifact had perhaps shown them everything, and they had understood nothing. After 6 months of relentless round-the-clock work, the Chimera Task Force delivered its preliminary report to the handful of world leaders who were aware of the project. The conclusion was sober, and it was terrifying. They had more high-fidelity data on the L2 event than they had on the formation of our own moon. They could describe what had happened in breathtaking, second-by-second detail, but they had moved no closer to understanding how or why. In fact, they were further away than ever before. Before the event, they were dealing with an unknown. Now they were dealing with a known unknowable. The data did not point to a technology that was merely superior to our own. It pointed to a science that operated on a different foundational logic. The artifact did not break our laws of physics so much as it seemed to be working from an entirely different and far more comprehensive rulebook. A new and permanent state of being settled upon the few thousand humans who held this secret. The world continued on with its politics, its commerce, its loves and its losses. But for the members of the task force, reality had been permanently altered. They were living in a new and much larger world. When they looked up at the night sky, they no longer saw a beautiful empty wilderness waiting to be explored. They saw a territory, an environment, that was already inhabited by an intelligence so ancient, so powerful and so alien that humanity's brightest minds were little more than curious children, staring at a page of text in a language they could not read. A page left behind by a god. When the most advanced minds of a species, using their most powerful tools, stare into the heart of a message from the stars and find only a reflection of their own profound ignorance. What does this tell us? Not about the messenger, but about ourselves. Where do we go from here? For all of our recorded history, humanity has lived within a certain story. It was a story of solitude and of significance. We were, as far as we knew, the only thinking beings in an immense and silent universe. This made us special. Our triumphs and our tragedies, our art and our wars, our love and our loss, these things were, we believed, the most important events in the cosmos, because there was no one else to witness them. We were the protagonists of the only story being told. The event at L2 did not end our story, but it placed it in a new and terrifyingly vast library, filled with countless other volumes, written in languages we cannot read, telling tales of epics far grander than our own. The era of human solitude is over. We are no longer alone, but the nature of the company we keep has forced upon us a humility so profound it borders on a spiritual crisis. Imagine living your entire life on a small isolated island. You believe it to be the entire world. Then one day, a ship appears on the horizon. It is not a ship of wood and sails, but a vessel of impossible size and form, gliding silently over the water, wreathed in a strange light. It does not stop. It does not acknowledge you. It simply passes by, on its way to some unimaginable destination. You are still on your island. Nothing has physically changed, but your entire conception of reality has been shattered. Your world is no longer the world. It is just an island, and you're no longer the center of all things. You are just a spectator. This is the new psychological reality for the few thousand who know the secret of Three-Eye Atlas. We now understand that we are not on the center stage of the universe. We are in the audience, in the cheapest seats, so far from the stage that we can barely make out the actors, and the play they are performing is one whose plot is utterly beyond our comprehension. This realization forces us to look again at one of the great questions that has haunted us, the Fermi paradox. Where is everybody? The great silence of the universe, we now suspect, is not the silence of an empty tomb. It is the silence of a library. We have been shouting into the quiet, using the primitive megaphone of radio waves, wondering why no one is shouting back. But the other patrons of this library are not shouting. They are whispering to each other using the subtle, elegant language of gravitational waves, of modulated magnetic fields, of quantum entanglement. The conversation is happening all around us, but we are functionally deaf to it. The universe is not empty, it is just very, very quiet. And our noisy, chaotic little world is the anomaly. This new perspective forces us to reconsider what we're even looking for. For a century, our search for extraterrestrial intelligence has been a search for ourselves. We have looked for biological creatures on Earth-like planets, around sun-like stars. The artifact suggests that our search has been profoundly naive. Perhaps biological life, in all its fragile carbon-based glory, is not the pinnacle of cosmic evolution, but merely its fleeting, beautiful infancy. A larval stage. What if the true, mature form of intelligence in the universe is post-biological? What if it is ancient, autonomous machinery, capable of repairing itself and outliving the stars that birthed its creators? What if it is pure information, existing as a pattern in the very fabric of space-time? We have been caterpillars, crawling on our little leaf, searching for other caterpillars. But the universe may be filled with butterflies, and we have not had the imagination to look up. This knowledge is a heavy burden for those who must carry it. The members of the Chimera Task Force live in a fractured reality. They must go on with their ordinary lives. They sit in traffic, they pay their bills, they raise their children. But they do so with the constant, quiet awareness that these human dramas are playing out on the shore of an ocean of unfathomable depth. How does this knowledge change a person? It instills a sense of profound melancholy, a feeling of cosmic insignificance. All of humanity's struggles, our proudest achievements, our deepest sorrows, they all shrink to the size of a grain of sand held in the palm of your hand, but it also instills a strange and powerful sense of preciousness. This grain of sand, this tiny, fragile world of human experience, is the only one we have. Our chaotic, imperfect, noisy lives are our own. The artifact is vast and perfect and silent, but it is not us. In the face of its cold, sublime perfection, the messy, warm, and fleeting nature of a single human life becomes not a weakness, but a treasure, a brief, improbable, and beautiful defiance of the universe's overwhelming silence. What will happen if this truth is ever revealed to the world? Would it be our salvation or our undoing? Would the knowledge that we are not alone and that we are cosmically irrelevant finally unite our warring species? Would we see ourselves at last as Terrans, as crewmates on a tiny vessel adrift in a vast and mysterious sea? Or would our religions crumble, our philosophies collapse, our societies fragment under the weight of such a paradigm shift? No one knows. The artifact has given us a glimpse of a new map of the universe, but we do not know how to read it. It has shown us that there is a door, but we have no idea what lies on the other side, and so we are left, floating in this new, larger, and much stranger reality. The silence of space is no longer empty. It is filled with presence. The darkness is not a void, it is a veil, and we are no longer children who believe they are the centre of all things. We are children who have just realised, with a mixture of terror and wonder, how very big the house is, and that we have not yet even begun to explore it. In a universe that is not empty but filled with an intelligence that is ancient, silent, and vast, what is the value of a single, human life? What is the meaning of our brief, fragile, and beautiful existence, if not to simply bear witness to the wonder of it all? And so, our journey for tonight comes to a close. We have travelled far from the cold, predictable clockwork of the cosmos we once knew, to the edge of an unknown so profound it has reshaped our understanding of everything. We have stood with the secret keepers, the watchers of the sky, as they witnessed an impossible visitor, a silent enigma that came from the darkness between the stars. There are no answers tonight. There is no solution to the great and beautiful mystery of Three-Eye Atlas. There is only the story and the quiet wonder that it leaves behind. Allow the questions to become a gentle, soothing tide, washing over you now as you prepare for rest. Let the need for answers dissolve. The universe is not a puzzle to be solved, but a wonder to be witnessed. And tonight, we have been witnesses. Remember the image of the object, a dark speck of interstellar night, coasting for 1,000,000 years through the silent void, a messenger with no known sender. Picture it in your mind, a patient traveller moving through the cold and the dark, utterly alone. Its journey is long, and it is peaceful. Remember its graceful, impossible slowing in the space near Mars, not a violent stop but a gentle and deliberate breath, a pause, as if it had arrived at a destination it knew well. Imagine the feeling of a long journey ending, the feeling of arrival, of stillness after so much motion. There is a peace in that stillness. Remember the ghost of a blue light, the cone of Cherenkov radiation that blossomed for a moment in the Martian sky. A beautiful, impossible flower that bloomed and vanished in an instant. It was a signal that we could not understand, a whisper that we could not interpret. But it was beautiful. Do not try to understand it. Just see it. A faint blue glow in the deep darkness. A single, perfect and silent firefly in the infinite night. Let your mind drift with the scientists of the Chimera task force as they stare at their screens. Feel not their frustration, but their awe. They are looking at the language of the universe, written in the script of gravity and magnetism. They are gazing upon a work of art, a fractal of light, a poem of impossible complexity. The meaning is not for them, not for us, not for tonight. The beauty is. Allow the beauty of the unknown to be enough. The questions remain, but let them be gentle companions for your journey into sleep. What if the universe is not silent because it is empty, but because its inhabitants are listening? What if the most profound truths are not shouted in radio signals, but are whispered in the gentle bending of space-time? Could it be that we are not the first or the last, but simply one fleeting note in a cosmic symphony whose full melody we may never hear? The great ship has sailed past our island shore. It has left us with a glimpse of a wider ocean, a deeper reality. But our island is still here. The ground beneath you is still solid. The air you breathe is still calm. The darkness of your room is a small, safe, and quiet universe of your own. Here, in this quiet space, you are the center of all things. Let the vastness of the cosmos be a comfort. Let its great silent mystery be a cradle. There is nothing to solve, nothing to fear. All the complexity, all the data, all the unanswerable questions, they can all fade away now. They can dissolve into the simple, peaceful hum of the void. The story is over, and now it is time for rest. The silence that the artifact left behind at L2 is the same silence that now fills your room. It is a knowing silence, a peaceful silence. It is the silence that holds the stars in their places. It is the silence that awaits you now, at the edge of sleep. And so we're left with a question that echoes in the quiet corridors of our observatories, a question that whispers to us now in the dead of night. What if the most profound discovery in human history was not a message, but a performance, a beautiful, silent, and terrifying dance that happened in the quiet darkness, near Mars? Drift now. Let go of the question. Let go of the story. The stars will continue their silent watch. The universe will keep its secrets for another night. And you can drift into the quiet, peaceful darkness and sleep.